Several possible causes exist as to why ground fault circuit interrupter, or GFCI, breaker may trip after installing new electronic ballast fluorescent fixtures. Firstly, consider induced voltage. As suspected, the magnetic fields generated by the ballast can induce voltage on the metal parts of the fixture. This induced voltage can create a secondary circuit, causing current leakage and tripping the GFCI. Secondly, examine for a ground fault. There could be a ground fault in the wiring or fixtures themselves, allowing current to flow through the ground wire. Thirdly, look for loose connections. Loose connections in the wiring or the GFCI breaker itself can cause intermittent ground faults. Fourthly, check for a neutral ground bond issue. If the neutral and ground wires are incorrectly bonded together in the panel or at the fixtures, it can create a path for current leakage. To troubleshoot these issues, follow these steps. 1. Double-check the wiring. Ensure that all wires are properly connected, with no exposed or loose strands. Tighten all connections firmly. 2. Test the fixtures separately. Disconnect one of the fixtures and test the GFCI breaker. If the breaker holds, the issue may be with that particular fixture. Swap the fixtures to determine if the problem persists. 3. Check the ballast and wiring insulation. Inspect the ballast and wiring for any signs of damage or insulation breakdown. Replace any damaged components. 4. Verify the neutral ground bond. Confirm that the neutral and ground wires are bonded together only at the panel. There should be no other bonding points in the circuit. 5. Contact a qualified electrician. If you are unable to resolve the issue on your own, it is highly recommended to contact a qualified electrician for further troubleshooting and repairs. As a temporary solution, while it is not recommended to leave the fixtures ungrounded for safety reasons, one can temporarily replace the GFCI breaker with a standard breaker if needed. However, be aware that this does not address the underlying issue and may pose a safety hazard if a ground fault occurs. When dealing with electrical circuits, safety is paramount. Here's a more in-depth look at the potential issues and how to systematically address them. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock by monitoring the current balance between the hot and neutral conductors. If there is an imbalance, indicating that current is leaking to ground, the GFCI quickly trips the circuit to prevent injury. This is why it's essential to address the cause of the tripping rather than simply replacing the GFCI with a standard breaker. Induced voltage from the ballast is a common issue with electronic ballasts. These ballasts generate electromagnetic fields that can induce a voltage in nearby metal components, including the fixture housing. This induced voltage may be sufficient to cause a small current to flow through the grounding system, which the GFCI detects as an imbalance. To mitigate this, ensure that the fixture is properly grounded with a low impedance path back to the electrical panel. This can help to minimize the induced voltage and prevent nuisance tripping. A ground fault, on the other hand, is a more serious issue. It indicates that current is flowing through an unintended path to ground, which could be due to damaged wiring, faulty equipment, or moisture. Carefully inspect all wiring connections, looking for any signs of damage or corrosion. Pay particular attention to the points where the wires connect to the fixtures and the GFCI breaker. Use a multimeter to test for continuity between the hot and ground conductors, as well as between the neutral and ground conductors. If you find continuity where there shouldn't be, it indicates a ground fault. Loose connections can also cause intermittent tripping. When a connection is loose, it can create a high resistance path that generates heat and voltage drop. This can disrupt the current balance in the circuit and cause the GFCI to trip. Tighten all screws and terminals securely, making sure that the wires are properly seated in the connectors. If you find any corroded or damaged connectors, replace them with new ones. A neutral ground bond issue can also lead to GFCI tripping. In a properly wired electrical system, the neutral and ground conductors are bonded together only at the main electrical panel. This ensures that there is a single point of reference for the grounding system. If the neutral and ground are bonded together at any other point in the circuit, it can create a parallel path for current to flow, which can cause the GFCI to trip. Check the wiring throughout the circuit to ensure that the neutral and ground are only bonded at the main panel. If you find any additional bonding points, disconnect them. When checking the ballast and wiring insulation, look for any signs of damage, such as cracks, cuts, or abrasions. Pay particular attention to the areas where the wires pass through metal enclosures or are exposed to heat. Use an insulation resistance tester, also known as a megometer, to test the insulation resistance of the wiring. This will help you to identify any insulation breakdown that may not be visible to the naked eye. If you find any damaged wiring, replace it with new wiring of the same gauge and type. Testing the fixtures separately can help you to isolate the source of the problem. Disconnect one of the fixtures from the circuit and test the GFCI breaker. If the breaker holds, it indicates that the problem is likely with the other fixture. Swap the fixtures to see if the problem follows the fixture. If it does, it confirms that the fixture is the source of the tripping. If the breaker still trips with only one fixture connected, it suggests that the problem is elsewhere in the circuit. When contacting a qualified electrician, be sure to choose someone who is experienced in troubleshooting GFCI circuits. They will have the knowledge and tools necessary to diagnose and repair the problem safely and effectively. They can also perform a thorough inspection of the entire electrical system to identify any other potential hazards. Remember, electrical work can be dangerous, so it's always best to err on the side of caution. If you are not comfortable working with electricity, or if you're unsure about any aspect of the troubleshooting process, call a qualified electrician. Finally, the temporary solution of replacing the GFCI with a standard breaker is not recommended, as it bypasses the safety protection that the GFCI provides. It should only be considered as a last resort, and only if you are certain that there is no ground fault in the circuit. Even then, it's important to remember that it's only a temporary fix and that you should still address the underlying cause of the tripping as soon as possible. Electronic ballasts can sometimes cause compatibility issues with GFCI breakers. Some older GFCI breakers may not be able to handle the high-frequency switching of electronic ballasts, which can lead to nuisance tripping. In this case, you may need to replace the GFCI breaker with a newer model that is designed to work with electronic ballasts. Look for GFCI breakers that are specifically labeled as being compatible with electronic ballasts. Another potential issue is the length of the wiring run. Long wiring runs can increase the capacitance of the circuit, which can also lead to nuisance tripping. This is because the capacitance can create a small leakage current that the GFCI detects as an imbalance. To mitigate this, try to keep the wiring runs as short as possible. You can also try using shielded cable, which can help to reduce the capacitance. In some cases, the problem may not be with the fixtures or the wiring, but with the GFCI breaker itself. GFCI breakers can sometimes fail, especially if they are old or have been subjected to repeated tripping. If you suspect that the GFCI breaker is faulty, try replacing it with a new one. Be sure to use a GFCI breaker that is rated for the correct amperage and voltage for the circuit. Also, consider the age of the home. Older homes may have electrical systems that are not up to current standards, which can make it more difficult to troubleshoot electrical problems. If the home is very old, it may be necessary to upgrade the entire electrical system to ensure safety and reliability. This can be a significant investment, but it's often worth it in the long run. Furthermore, consider environmental factors. If the room used to have a spa in it, there may be residual moisture or corrosion that is contributing to the problem. Moisture can create a conductive path for current to flow, which can cause a ground fault. Clean and dry the area thoroughly, and check for any signs of corrosion on the wiring or fixtures. If you find any corrosion, clean it off with a wire brush and apply a corrosion inhibitor. Here are some additional tips to keep in mind when troubleshooting GFCI circuits. Always turn off the power to the circuit before working on it. Use a non-contact voltage tester to verify that the power is off. Wear rubber gloves and eye protection to protect yourself from electrical shock. Work in a well-lit area so that you can see what you're doing. If you're not sure about something, ask a qualified electrician for help. Understanding grounding and bonding is also critical. The grounding system provides a low impedance path for fault current to flow back to the source, which allows the overcurrent protection device such as a circuit breaker or fuse to trip and clear the fault. The bonding system connects all metal parts of the electrical system together, which ensures that they are at the same electrical potential. This helps to prevent electrical shock by minimizing the voltage difference between different metal parts. In summary, troubleshooting GFCI tripping issues requires a systematic approach. Start by identifying the potential causes such as induced voltage, ground faults, loose connections, and neutral ground bond issues. Then follow the troubleshooting steps outlined above to isolate the source of the problem. Remember to always prioritize safety and to contact a qualified electrician if you are not comfortable working with electricity.